Hello guys, this is Dr. Antoine, your coach in data analysis using R2. Today I'm going to show you how you can perform low-based regression using R. Remember, when you want to analyze the impact of independent variable on dependent variable, you have to check whether the assumptions of linear regression are met or not. When the assumption of linear regression are not met, you have to find other methods that can help you to analyze your data based on your prior studies or your theories. Now, today I'm going to show you how you can perform low-based regression, which can be used where linear regression cannot be applied. Normally, linear regression and low-based regression have same result when the proper conditions are met. The importance of the use of low-based regression is that low-based regression can downweight outliers. Now I'm going to show you how you can perform low-based regression in R, and we see and compare the result of linear regression and low-based regression. Now let's go with data importation. Now this command allows us to import our data in R. Okay, this command allows us to have all numbers, not in scientific and formal. And this is to see how the number of observations and number of variables we have in our data. This one, and as you can see now, the results are here. This command allows us to see whether our data were correctly imported in R. This command. Now you can see we have our variables: GDP 2020, FDI 2020, export 2020. As I can remind you, I use data retrieved on a World Bank database. This is the GDP, gross domestic product, for 2020. Then this is FDI for direct investment for 2020, and this is export of goods and services for 2020. These data were used when I was showing you how you can make data preparation. This is just a data collected so as to help you to see how you can conduct some statistical tests using R. And before you perform an analysis, you have to analyze whether your data have missing data. That's why this command allows us to check the number of missing data and the percentage of missing data. Before you perform this command, you need to run this command, question R. This is the right one that can help you to perform this command. Now let's see the number of missing data in our data set, and then as you can see here, export has 57 missing data, which represent 21%. GDP has 24 missing data, which represents 90%, and FDI has 22 of missing data, which represent 8%. Now this is just to see whether your data has missing data or not. Remember, it is important to check this because when you have the variables which more missing data, this may be an indication of the difficulty of your question or whether your data will not correctly. Your data will have some problem in gathering information. Okay, now let's remember, I have said that there are many ways that you can deal with missing data, whether you can make what we call imputation, you can use mean or median or mode. Imputation refers to replacing missing data by the mean or median or mode. Now let's decide to delete all those observations with missing data. Here, this command allows us to delete all observations with missing data. Now let's delete all missing data. Now, the first condition is to check whether or not assumption normality is met or not. Remember, all parametric tests have assumption on data normality. The null hypothesis for normality is that our data are normally distributed, while the hypothesis is that data are not normal distributed. When the p-value is less than 5%, we conclude that our data are not normally distributed, and when the p-value is greater than 5%, we conclude that our data are normally distributed. Now let's check with GDP to see whether or not our data are normal. GDP is normally distributed. As you can see here, GDP, the p-value of GDP is less than 5%, and then we conclude that the null hypothesis is rejected, and we say that GDP is not normally distributed. Let's check with FTI. The same comment, we can just see if FTI is normally distributed. As you can see, the p-value of FTI, the p-value is less than 5%, and we conclude that our data are not normally distributed. Let's check with the exports to see whether exports are normally distributed. As you can see here, the p-value is less than 5%, and as conclusion, we conclude that our data are not normally distributed. Remember when I was talking about normality checking, I said that you can check normality visually or numerically, and this we using Shapiro test, normality test. We are checking numerically, but you can do also visually. And when you want to check this visually, you can use this comment, but you have to install this package. Let's see. Let's check visually whether GDP is normally distributed. Let's see the graphic. You see it takes much time because my computer is using various software, that's why. Now, as you can see here, our GDP is not normally distributed as indicated by Shapiro normality test, as data are far from this line, this one. Let's check with FDI. We have to wait a moment. We see the same result. As you can see, there are many observations which are far from this line, such line. Okay, now we can see the same. We can check with FDI. Now the question is, what are those countries which are considered as outliers? How can you answer this question? Maybe you want to see those countries which are considered as outliers. And here we can use this comment, this library performance, and this library performance allows you to locate or to see the positions of those countries which have outliers observations. Now, when you run this comment, you will see the positions or locations of those countries with outliers. Now, if you want to see those countries, the name of those countries, we use this comment, and this is included in this package. Now, what you have to do is just to copy and paste all this. But as I have just finished, I do not need to do it again. These, as you can see here, these numbers are the same as this one. Okay, now let's see those countries which are considered as outliers. This is for GDP. Now let's see. We have to go slowly. Okay. Now there are many countries. But now, as you can see, now you see here are countries, country name. This is GDP. Africa, Eastern and Southern, Africa, Western and Central, Australia, Belgium, Brazil, Canada, and so on. Those countries have a GDP which is considered as outliers when consider the majority of observations or the majority of countries. Okay, you can do the same for other variables like FDI and GDP. It is the same comment. Now, let's fit linear models so as to see the result of this model. Remember, we are not interested in linear regression, but it's better to remember how you can even fit the linear model. Here, this is the comment, linear model, GDP, this is dependent variable, sorry. This is independent variable, FEI, and this is also independent variable. Now this is how to learn. You can learn a linear model. Here data indicate where you have saved your data. Remember, we are using data with no missing observations. Now let's see the summary of this model. Let's see whether the variables are significant or not. Discover summary here. Now, as you can see here, the estimate of coefficient of FDI is 21.29. The coefficient estimate of FDI export is 2.6, and as far as significance is concerned, as you can see here, the coefficient of FDI is significant. The coefficient also of export is also significant. Remember, the null hypothesis which being tested here is that the independent variable has no effect on dependent variable. Now, as you can see here, the null hypothesis is rejected. When it is rejected, that means these independent variables have effect on dependent variable, which is GDP. Now, as you can see globally on this model, as you can see, multiple r squared. Now you can see it is 0.97, and adjusted r squared is 0.97. Exactly the same. Now this means our model can explain 0.97% of change, or no, sorry, this model explains 97% of change in GDP. That's what it means. And globally, generally, this model is significant as the silver p-value is less than 5%. Here, the null hypothesis is that the independent variable have no effect on dependent variable. Now, this null hypothesis is rejected. Now, as we said, the conditions of applying linear model are not met, especially normality. Now, let's see what is the result of logistic regression. Now, remember I said the advantage of using logistic regression is that the logistic regression has the power of down weights those observations which are considered as outliers. Now we have to run this comment. Now we see how we can fit the model LM linear model lobbyist. Now this comment, this one is the same as here. You can see that there is no change. The comment only has changed. Now look, let's see the result summary of this model. This one. Look here the result here. Now remember, in linear model the coefficient of FDR was significant but was positive. But here, when you use zero-based regression, you see now the coefficient of FDR is negative and significant. Remember, let's see here the result of FDR in linear model. You see here the coefficient of FDI was, look, FDI was 21, export was 2. But when you use low-based method, you see the coefficient of FDI becomes negative and significant, but export remains, the coefficient of export remains significant and positive. Now, we can compare our model by using sigma, which means those residual standard errors. Now, as you can see here, when I run this comment, this one, sigma, the best model is the one which has residual error which are small. Now, as you can see here, let's show this one. This is the same. I just want to see to show you. So now, as you can see here, okay. Let's show you sigma here in your list model. Look, this one, Now you can see here. Now, as you can see, this one has a small residual standard error. As you can see here, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. This is smaller residual standard error than when compared to this one. Now, this you can use also our companion. Can give you the summary of these models. Okay. Let's see the summary of this comparison. Now, this is the summarized results for these slides. Now, what is the conclusion? As you can see here, when you use linear regression, the coefficient of this FDI is positive and significant. But when you use low-based regression, the coefficient of FDI is negative and significant. Remember, when you are interpreting your results, you have to interpret your results based on your prior studies or prior theory. Now, when you use linear regression, the conclusion is that FDI has positive impact on GDP. But when you use low-based regression, we conclude that FDI has negative impact on FDI. But as you can see, it is better to choose the best method to which is suitable for your data analysis, because when you use the wrong method, the conclusion of your conclusions are not correct at first. Not correct. Now it is advised to analyze better data and choose the correct method to be used when you are performing your data analysis. Okay friends, this is the end of the presentation. I think this video will help you in your data analysis. When you found this video helpful, you can share it, and you can also like it. And if you are not subscribed to our channel, don't hesitate to subscribe. I will continue to share with you some other videos that can help you to increase your knowledge in data analysis. Thank you very much for your attention. Bye.